Thank you. What's a fat? Get my shield on.
Isn't it amino acids connected to I know it has like amino acids.
Amino acids connected to
triglyceride. Is that it?
It is a triglyceride.
Is it carbohydrate?
It's amino acids, or not amino acids, it's fatty acids connected to glycerol. If you take, and you gotta kind of aim that camera right, so I walk out of the screen. If you take a glycerol, bam, we got one here, and you connect it to 3 fatty acid chains, bang, bang, now you've got a fat. And y'all know whenever we connect one molecule with another, what tends to happen whenever you make those connections?
Oh, and doesn't a bond, like an
OH will come off one end, an H will come off another, and you'll form what?
H2O.
Water, H2O. What do we call that type of reaction?
Dehydration synthesis.
Dehydration synthesis. Is anyone with me? This is a review from last time. So, do you show the screen too?
It doesn't like go up that high, but I can.
Okay, so let me show you how to do it. So there's a little thing here that you can turn and loosen it and make it.
Oh, you gotta go all the way down here to this.
Yeah, like that.
Okay.
Does that make sense?
Make sense.
Okay. So, and then you can tighten it up. Yeah.
There we go.
So, let's take a look. Some fatty acid chains, excuse me, some fatty acid chains are what we call saturated. That means they're all single bonds between the carbon atoms, except for this carboxyl group on the end. That has a double bond going to an oxygen. But ignoring the carboxyl group, fatty acids have all single bonds. If they have all single bonds, they're called saturated fatty acids. Have you ever heard that word saturated? It means holding as much as possible. So if it's saturated, it has all the hydrogens that it can possibly bond to. Look at this. This next one is unsaturated. Bam. You see the difference? This is called oleic acid, and it's unsaturated. That means it's got a double bond somewhere in the structure, and that means there's not as many hydrogens as possible. So it's not saturated with hydrogens. It's unsaturated. So look at the difference. Saturated, that slide. Unsaturated, that slide. You see the difference? I'll toggle back and forth. I'm toggling, y'all. You see the difference? As I toggle, I just like to say toggle. See the difference?
Yes.
Thank you for answering. What's that? Ah! What's going on?
Toggling. Toggling too fast.
It was self-toggling.
It's becoming self.
Yes. Good observation. When you have a double bond in the structure, it usually, or it often will make it bend. If it's in the cis arrangement, it'll make it bend. If it's in the trans arrangement, it won't bend. Do y'all remember cis versus trans?
Did it take 5 tenths?
What?
This?
Do it.
Cis versus trans? Cis versus trans? I might get one hit. One hit. 2 hits is all I can get. So anyway, Yes, sometimes when you put a double bond in the structure, it will make it bend, and that'll change the way the chain looks. Here is a drawing of alpha linolenic acid. And why is it just zigzag lines? Why aren't there atoms there?
Because they just expect you to know this kind of stuff.
They expect you to know that at every point is a carbon. Whenever you're drawing, the shorthand way to draw organic molecules is to leave out the carbons in the chain and to leave out the hydrogens that they're attached to, that are attached to the carbons. So if we leave out the carbons and hydrogens, you're left with nothing but lines. The lines represent the bonds. So there's a carbon there, carbon there, carbon there, carbon
What
there.
about on the other side of the H's, or the hydrogens?
So right here there's a carbon, and there's a carbon. And they drew those H's. I guess when you're doing the shorthand, you still draw the H's if they're next to a double bond. That's a double bond.
So all the spikes from the CH3 to the H all have carbons as well?
Yeah, carbon there, carbon there, carbon there, carbon there. Does that make sense?
What about where it's double bonded there?
Where it's double bonded, there's still a carbon. There's a carbon there and a carbon there.
Oh.
Because carbon has 4 bonds, right?
Okay.
So look, 1, 2, 3, 4. There must be a carbon right there. Does that make sense?
Thank you, Sensei.
Are y'all ready to build these molecules in the lab?
I would love to.
Now, there's if you take a straight chain, this is a fat. Let's see if they talk about this. No, they don't. Let me back up a little bit. This is this triglyceride that has all straight chains, and when you have saturated fats like this is a saturated fat, all single bonds. It's nice and compact. If you put another fat next to it, let me put another fat next to it. Let me borrow some of these from over here. You can really stack them closely together like this. Here's one fat molecule, here's another fat molecule. You can stack them close together. They can get in together real tight. It makes the fat real dense. Solid fat, like the fat that's under your skin, the fat you cut off a steak, that's solid, right? Those are saturated fats. Butter is an example of a saturated fat. It's pretty solid, especially when it's cold. It's real solid. Now, if you were to throw in some unsaturated fatty acid chains, watch this now. If you're not watching, you need to watch. I'm going to replace a saturated fat with an unsaturated fat. And I'm going to replace this one right here with an unsaturated. Now, you can't put these together very closely because of these bent side chains. They just aren't going to stack together very well. Maybe this one has 2 of them. Unsaturated fats form liquids at normal temperatures, at room temperature. Oils, corn oil, olive oil, vegetable oil, they're all unsaturated fats. And that's why they're liquids. Yeah.
What about like petroleum? Is that something totally different?
I'm not sure. I want to say petroleum is mostly carbohydrate. These. But it may also have lipids in it too. You'd have to look that up. It's a great question. I just can't answer. A lot of questions I can't answer. It's pretty incredible that I don't know something, but, you know. Now, a wax. What does a wax look like? Here's what a wax looks like. It's usually two fatty acid chains just connected by a bond. I can just draw a bond between these two, bond those together, and that's usually a wax looks something like that. You know the wax that's on the surface of a leaf? Earwax, wax that's in a beehive, beeswax, and all are molecules that look like this. It's just the fatty acid chains without the glycerol. And in biology, this is probably the most important fat molecule we'll run into. We really talk about it a lot when we're studying cells. Yes. This is a phospholipid. How do you make a phospholipid? Let's just turn this thing sideways. You take off and only have two fatty acid chains. One of them bent, one of them straight. Actually, I think it looks like this. And on the attached to the other carbon is not another fatty acid chain. It's a phosphate group. And often there's a nitrate group on it too. This is a phospholipid. Phospholipid. And millions of these, if you put them side by side with one another, let's put another one here. And of course there are enzymes in cells that build these things. And they sit side by side, and they sit kind of close together. Now, if you had millions of these things, they align in such a way. See, the phosphate, it has a negative charge to it. I don't know if you can see that little negative sign from where you're sitting, but it's there. And this nitrogen has a positive charge to it. There should be a little positive sign. Yep, it's right there. Anyway, this is a charged group. So whenever you put a phospholipid in the membrane, it'll automatically turn where the charged groups are all facing the water, which is there's water outside cells. There's also water inside cells. So you'll have a layer of phospholipids that sits upside down here, turned in the opposite direction. Kind of looks like this, going up. Like this, see? That, something like that. And so you have a layer of phospholipids this way, and a layer of phospholipids on this side, and that makes what we call the phospholipid bilayer. Can you see why it's called a bilayer? Layer on top, layer on bottom. And see these tail parts, I don't know if you remember this from biology, we call them hydrophobic. They're scared of water. And these head parts are hydrophilic. They're attracted to water. They love water. And so they point up and down toward the water. Do you like my little model?
Yeah.
Can you tell that this is this?
Yeah.
Can you tell?
Yeah.
See how there's a double bond there? Turn. See how there's the glycerol right there, 3 carbons in a row? You see the phosphate group? Does it have the nitrate group in it?
Yeah.
See that R? R stands for the rest. And it usually means there's something else up there, which in this case is this nitrate group. Huh? Do you like it?
Yeah.
What about you, Meryl? Yeah? Are you wearing a Rolling Stones t-shirt? Isn't that against dress code?
Yeah, girl, this year it's switched. Like Girls never get dress coded, but not on the guys.
You can wear t-shirts?
Yeah.
It's a very cool t-shirt.
I can't wear Openstax.
It's a very cool t-shirt.
Tomorrow I'm wearing a t-shirt.
I don't think you can wear that, but you know what? I've been wrong before. I was wrong today about something.
About.
I think I was right, and I thought I was wrong. So I was wrong about being wrong.
Dang. Love when that happens.
I don't not use double negatives. It's a joke of the day. Okay, so you can see how phospholipid bilayer forms in cells. That's what I tried to build here. If you just threw a bunch of these in water, they would naturally form a bubble. It's called a micelle, with the tails pointing inward and the heads pointing outward. And they'll just do that. These aren't even alive, and they'll do that because of the charges and the hydrophobic and hydrophilic nature. So organization in nature can happen even for non-living things. And so we think that that's how cells formed. A bunch of fats in the water formed circles and eventually bubbles and with stuff inside of it, and then eventually you get a cell. That's what we think happened. Now, probably when you're standing there looking at me, you go, gosh, he's so big, he must be on steroids. But I'm not. This is all natural. But that brings us into the conversation. What is a steroid? This is a steroid molecule. The most common steroid is cholesterol. You may not have known cholesterol is a steroid molecule, but it is. And cholesterol is a molecule that you need. It actually exists in membranes. You can put a cholesterol molecule in a membrane, and it'll help stabilize the membrane. You might have a cholesterol molecule in here that kind of look like this a little bit. And they have a tail. That's my drawing of a cholesterol molecule. The head of the cholesterol molecule faces up towards the water. The tail goes down to the middle, and it sits in the membrane, and it'll sit in cell membranes and help stabilize the membranes. Keep them from coming apart too easily. Only animal cells use cholesterol. Plant cells don't need it because they have a tough cell wall that keeps the membrane from coming apart. So that's why you have to worry about, if you're worried about your cholesterol, you have to eat plants, not animals. You have to go vegetarian a little bit. Because if you're just eating meat all the time or eggs, you're getting a lot of cholesterol in your diet, which if you have high cholesterol, you need to remove that. Have you all ever heard this before? If you ever have cholesterol problems in your life, just eat animals. They don't have, just eat plants. Animals have cholesterol, but plants don't in their membranes. And so cholesterol, if you get too much of it, can clog up your arteries and cause high blood pressure and be bad for you. You'll have to check your cholesterol whenever you go to the doctor when you get older. Right now, you probably don't have a problem with it because you're young and active. And most people who are young and active don't have cholesterol issues. But once you get old like me, you got to get your cholesterol checked. It might be too high. Is mine too high? No, perfect. Okay, so anyway, I hadn't had it checked in a while though, so we go get it checked. Is that fun? Are y'all having fun?
Yeah.
You want to try and build some of these bad boys?
Yeah.
Here's what I want you to do. You and your group grab a molecule from the board and let's try and build it in the lab. Let's try and build a fatty acid. Okay?